And it's a bit like, you try to build a car and, like without really understanding I don't know, like the, what what does it take to build the right chassis or whatever. So you take like, you just take four wheels, you put them there, you tie them together, you put like the shell of the car, and then it's a car. It looks like a car, right? But then, like in the first turn, it will fall apart or it won't turn right or whatever, right? I mean, you need to understand, like how the suspension works, the dynamic, all those kind of things. So one of the challenge in data science is when you start too high, so you take very complex model, you will get some results rather fast, especially today when a lot of tools are commoditized. But by doing that, you're actually it blocks you from really understanding well the data.
Welcome, everyone. Our today's podcast guest is someone who has more than 2 decades of experience in data science, AI, and machine learning. He's not only a data science and machine learning expert, but in past he also founded his own company, which was around managing big human genome data, which is way beyond the blockchain concept that we have right now. I personally learned a lot from him by meeting him in person, and I think there's a lot to learn from him about data science and machine learning. On this specific podcast, we haven't went into much detail or technicalities of data science and AI, but we touched upon the initial steps, the crucial steps that one should focus on when an individual or an organization wants to start a data science, machine learning, or AI vertical. So, with that, let's welcome our today's podcast guest, Adrian.
It's really when I was in UK, it was really insightful to have conversation with you, and I thought to bring you on the podcast because I think from you and having this conversation, our audience can learn a lot of insightful thing about the data science itself, how to go about building AI model, how to go about starting a vertical if someone wants to do so, and what are the areas that people should focus on while they are starting something with AI. So really happy to have you on the podcast as a guest, and looking forward to our insightful conversation.
Really exciting to be here, and likewise, really enjoy the discussion. So yeah, should I introduce myself quickly just to know?
Yes, please go on.
Yeah. So my background is very much around data science, computer science. So I studied computer science and in my undergrad. So can think about my minor is computer science. But then, as I moved towards my graduate studies, I was looking. I was quite passionate about statistics, and I would say stochastics, which is like theoretical statistics. That was like when I was doing my undergrad. And then as I moved forward, I was like, I wanted to go more. At that point, I was calling applied statistics, or I mean, that was like around early 2000s. And yeah, I was looking for different areas where you can uh, explore interesting problems. And of course, there were like computer vision and imaging and various different things. Though like in those areas at that point were probably not as hyped as they were today. Um, so they were interesting. But what caught my attention at that point was uh, computational biology. So I was at Max Planck Institute for Informatics at that point, and I start talking with the guys in the computational biology and algorithmics group, and I really got excited because like all of a sudden they had a plethora of data problems. So like they 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 had a lot of interest. They could measure data or whatever. They had very interesting data sets, and they needed to make sense of them. So that brought me from that computer science, statistics, more towards computational biology and, like statistical
What do
computing and data mining. Yeah.
for our audience, just sorry to interrupt, for our audience,
Yeah.
if you need to explain the computational biology in very layman language or simple language, what is that?
Yeah, so I mean, that's a that's a good question. Didn't thought about it for a while, but basically, you have a you you want to solve some biological you want to answer some biological questions through algorithms or learning from the data, right? So, for example, in drug discovery, you want to you want to develop a drug for a particular disease, and to develop that drug, you need to target a protein, right? So, this protein is like a snowball, what was like a ball of wires, and basically you want to fit a particular other small molecule that, right? So obviously you have to use computational methods to figure out what is the right shape that works, like that you can fit there, or you want to do various simulations, or you want to predict, like the next amino acid in a particular sequence. So, so you want to solve some biological problem to compute through computational uh, means. So that's what people will kind of refer to computational biology.
Interesting. Yes, please go
Yeah.
ahead.
Yeah, so I basically joined that group, and I start working on functional biology. At that point, was gene expression analysis. So developing methods to try to find out, like what are the genes that, uh, like parts of our DNAs that are different between disease and control groups, and so on and so forth. And like, so I did quite a few. I developed quite a few methods. Interesting fact, and it's so interesting. I mean, I keep on going back to this, and I'll tell you a bit later why. Because um, part of my work that I did there, so I developed a package in R and uh, for a suite for a library called Bioconductor, which is quite used that resource by like bioinformaticians, biologists, all those things. And the interesting thing is, I was so passionate at that point to actually solve that problem, and I put a lot of thinking into it. And the cool thing is, I started developing that in 2005, so it's almost 20 years ago. The cool thing is that that package is still used today, and I still get emails. And like, I never really planned it. Like, hey, I want to develop something that like will have this longevity, and I didn't maintain it for like, thankfully, I must say I didn't maintain it for like 13, 14 years now. But one thing that keeps me thinking back to that is, if you develop something so if you work on something and you're passionate about it, and it tries to solve a problem, and you try to like, not just hack your way around it, but like, you try to put a bit of thinking. So like, you try to design it a bit. Most of the time you end up building a very useful tool that like, and like that, in this particular case, like, people still find it useful. And like, for me, it's like shocking, because if I would have thought at that point I want to build something that like would last for a decade or whatever, like, I would have probably overthought it. But I was just build it because like, I was learning some of the tools I was using at that point, and I wanted to build something that was robust to solve my problem. I want to generalize it. I want that thing to be generic enough to do all those things. And anyway, so very interesting thing for me always is like, if like if you build something that you're passionate about, you have a high chance that other people will also love using it. So yeah. So anyway, to move on. I know 12, 13 years ago, I I so I was wrapping up my studies there, and then I moved to Cambridge. I got a job in was kind of a dream job for me at that point because um, mid to 2000 it was the boom of or whatever. In 2003 we sequenced the human genome, right? So we figure out what uh, the structure of the like how the genome looks for an individual. And then like from 2003 to 2010 there were a lot of push to for the technology to get commoditized. And one of the companies that was very successful actually came out from Cambridge. And that company, the startup was called Alexa, and that got bought by a US company called Illumina. And in 2010, 2011, I got a job at Illumina to work in the, again, computational biology group. So doing, like developing algorithms and doing machine learning on genomic data. So for me, it was like, wow, great. Like now all of the sudden, way more data. I mean, like the human genome is huge, as you probably know. So, like just for the audience, it has 3.2 billion letters, and like that's for one individual. And then if you start looking, and each individual has 3.5 million variants, and then like when you have cancer, some of these variants are going haywire, and like then you need to kind of start comparing across like multiple individuals to kind of get some insights. So it's really a lot of interest, like a lot of data, so huge amounts of data and a lot of interesting problems. So for me, it was really, really exciting. So I joined Illumina beginning of 2011, and I started doing analytics on genomics data. And I did that for around 1.5 years until the computer scientist in me kicked, like, or whatever, was like, hey, we can actually do these things a bit more, like, not structural, like more sound or whatever, more reproducible or more, like, so I was like, I start moving a bit more from um, doing meta development, algorithmic design, data science, more towards building those analytical platforms. So I got involved in a few projects there. One was, and again, that was when 2012, 20, no, 20, yeah, 2012, 2013, when Illumina at that point was building this cloud platform called Bayspace, where basically you load the data, you can do, or you can apply various tools on the genomics data and whatever. So I was part of the team that developed that. And
So it was you were working on human genomes, and for our audience, it's like I've been into and I'm learning about this segment, which is really really exciting. It's about you are working with human genomes to predict certain analysis on their body. If there are cancer cells, how they'll work, and there are also genome sequencing or something like that. So what part you were working on? Were you predicting those?
no,
Uh,
sorry,
in
actually, I lost you for a bit.
Yeah. So I
So
was just
like 20,
asking.
30 seconds.
Yeah, am I audible now?
Yeah, all good, all good.
Yeah, so I was just wanted to understand what was your role in the genome
Hmm.
data science that you were working on? Were you were you building the
Yeah,
algorithm from scratch for machine learning to predict how these certain drugs will work on certain cells, human bodies, based on the genome of particular person? And as you said, the billions and trillions, billions of data with the trillions of possibilities, permutation, and combinations of those data. So how
yeah,
difficult it was to work
yeah.
with?
So I mean, obviously, it was a mix of things. So I worked on a few projects. I mean, and projects were from, you know, analyzing and understanding the data. So that think of it about more exploratory data discovery or something like that. So one of the big project I did was we actually rebuild the primary analysis metrics framework. And again, I mean, we don't have time today to discuss on that, but a lot of very interesting um, learnings there from a product perspective. So basically, that was like data coming directly from the instruments, and then you are um, you are summarizing the data, and then like the scientist needs to interpret it from a QC perspective, all those kind of things. So like, and basically what we did there, just very shortly, we introduced some standards on the way how we were storing different some of those objects, and like such that we can apply like easy statistic or whatever data science tooling on it and whatever, all those kind of things. So that was interesting. But I mean, you I mean it's a huge field, right? Genomics, it's a huge field, and you can you can look at a lot of different aspects. The things I was maybe to mention, two things I did was, one was looking at cancer chronicity. So for example, when you measure when you take a sample from from a like individual tumor, I mean that cancer, you don't know what like how old that cancer is, right? So like that started at some point in time, let's say 4 years ago, 3 years ago, or whatever, and then it developed, right? And then you want to understand what is the driver mutation, right? So you basically want to go back and say like, okay, I have this burden of mutation, so what I'm measuring now, and then like you start taking a few other individuals, and then you try to kind of think about, I don't know if you ever seen like a phylogeny tree, like a direct classical graph, to say like, oh, this is what I see today, maybe this was what happened before, and so on and so forth, such that like you can start thinking about going towards the root cause, right? And the root cause will be what was that first mutation or whatever first couple mutation that triggered all these things. So again, that's learning from the data, right? So you get all these kind of things. Uh, Another one was what at that point and again, think about this is 10 years ago, we were calling multi-sample cancer analysis. Again, this was part of that. But another part of that was identifying hotspot mutations. That's how we were calling them. So, like you have a cohort, let's say 50 individuals or 100 individuals, you have their genomics data, and then you try to see like, are there some mutations that like have a particular behavior within this population? And again, that's a learning problem, and you can like, there are different ways of solving it. Some of them you actually need to develop some let's say computational algorithms. Some of them you can use like more let's say state of the art AI from today, where you say like this is what I've seen before, like can you learn those relations, so on and so forth. But like, so you can go call it bottom up or top down approach to those things. But again, maybe like maybe we should move on, because that was kind of 10 years ago. I'm mindful, I'm taking a bit too much
And that's what
to my background. Yeah.
from the organization perspective, that's what it for to the organization, it helps them to focus, maybe narrow down the drug research that they are doing, or develop some molecules which works on certain genomes accordingly.
Uh, in that particular case, that wasn't this thing, because Illumina is producing the technology and the instruments for other organizations to do the research.
Okay.
You're talking about. So Illumina, it's call it a platform or what? So it's a technology provider, right? So we were basically, but of
SaaS
course
platform.
we're trying to understand. Yeah, not SaaS. I mean, it's a technology, right? Instruments and reagents and everything, right? So they provide you the tools that you can
Okay.
do the sequencing. Anyway,
Okay.
so from Illumina, and maybe you heard part of the story when you call in your previous podcast when you talked to Fiona. So at Illumina, I met Fiona, and then we jumped. We quit our jobs and we started a company called Repositive. Where at Repositive, basically, we wanted to solve the problem of democratizing access to human genomics data. So it was like we wanted to help people that scientists in industry and academia that are that need data to validate their hypothesis uh, to match make them with the people that have data, right? So we built this Discover platform. So we went to index various data repositories, and we built this web portal where you could go and search across all these data repositories to do the very interesting. We spent around 5 years, um, like starting from the idea, building the product, all those kind of things. Can tell you a, a lot about that. We did less data science there because that was more, let's call it web platform development, and like more focused on whatever that product we were building towards going to a point where we had the data to do some interesting data mining, data science, AI type of challenges. I exited that business beginning of 2019, so almost 4 years ago. And then I wanted to kind of uh, there were a few things. So actually, I wanted to do a bit more data science, and I wanted to actually explore a bit more the clinical side, the healthcare part of things. So over the last 4 years, I built myself a portfolio of companies that I'm working with in different shapes and forms, from advising, mentoring. But um, when it's about the engineering, data science part, so I that's more the, let's say, hands-on work I'm doing with these businesses, with these companies, and those are from startups to let's say larger SMEs, right? And I mean those are like different, so it goes across health and life science markets. But like I'm kind of jumping in everything that is related to AI and ML. So basically, I'm focused on helping them define the data and the AI strategy for their business. And in some cases, as I was saying earlier, I'm also helping deliver that as well. So basically, I I get in, I start looking across, like, let's say, okay, what's interesting for uh, let's say they have an app for diabetes, or they have a therapeutics that they want to develop there. So, and understand, understand what's been done. I'll give you a bit of an example in a bit. So what's been done, where things are going, start speaking with some of their customer, understand the availability of the data, and like what technologies they can fit. Because I think one of the challenges I've seen today, especially with all the hype and all the talk around AI, many people think that is a uh, bolt-on solution. So like one that you can just take something off the shelf, throw it to your problem, uh, and solving your problem. In some particular cases, it works or whatever. It's a good start, but most of the time, it's not. And like you need to understand what it is. So yeah, so that's basically what I did over the 4 years. Just to give you just to go a bit back to what I was saying when. For example, I was helping a company that they were developing uh, a diagnostic device for heart. So basically, they were measuring different um, signals, different metrics from the heart. So think about some sound waves, or like we have all these wearables, or like you get that ECG. Um, uh, devices that like will understand, like will get the uh, ECG of your heart, whatever. So they were collecting a few of those signals. I can't tell you exactly what it is because like that's their IP. But basically, they were collecting all those things, and then they had this data, and then they were trying to build to get this device FDA approved. Again, the device was a mix of hardware plus the AI part of it. So, like how you process and how you learn from the data uh, to to get it FDA approved as a diagnostic for, let's say, coronary artery disease. Like, can we find out something? Like, can we diagnose if an individual has coronary artery or doesn't have coronary artery disease, such that we don't send them to um, or we don't send them to more invasive tests like catheter lab or like do some radioactive measurements, right? So we do a PET scan or whatever. um, so really interesting problems there because they had actually a lot of data, but so they have a lot of data, and you know they it was a cool, and also the problem is quite relevant, right? So one of the things I did, and obviously they were knowledgeable, but then they were like, okay, actually we have all these signals and all those things. Uh, we looked at what they did, and then we went and we start seeing, okay, what's the current state of the art? Can you use some of those technologies? Like how else can you take the data and map it? In data science, we call that feature engineering, right? So moving from, your measurement to, a new feature, right? And you can do that by combining a few features or adding new data and so on and so forth. So, what can we do, or can we use some of these, deep neural networks to do that and all those kind of things. So those are the kind of challenges I'm engaged in right now.
Great. Taking this example only, as you're currently working with multiple companies uh, as an AI or machine learning data science consultant, so to say, what are the general gaps that you see when people
Right,
or the organization start with building something on AI? What are the initial
right.
gaps that you find that people don't focus on, or they just take it very lightly, and that causes the rework or something not providing the desired output or something like that? So yeah.
Yeah, love the question. It's and I will give you a very short and boring answer, and I will call it process. So a lot of those organizations, um, again, they they believe that it's like uploading data in Excel and selecting some, like cells and like doing a graph, right? So they so on one side you have the naivety of, um, let's say, the management, so the people, the decision makers, or the stakeholders, and on the other side you have the naivety of some, let's say, um, data scientists or whatever, enthusiastic data scientists, which is good. I mean, you love it, but so you want to be energized and to want to try things, but having the right process, it's very, very, very important. And understanding that things that, for example, I mean, I like to say that data science is not engineering. I mean, we can discuss a bit about that, and I
Yeah,
would love
if you can just break it down.
yeah, yeah. So, but so on the process, it's just thinking that. So what I see a lot is like, oh, okay, cool, we can take these models that developed or whatever, they have it in this paper, I read this paper or these papers, and I'll take this and we'll implement it, and then we'll throw our data and it will work, right? And most of the time, people, so the naivety, especially from the data scientist side, so, and again, this is in companies that are, they, they don't have that data science, data engineering capability within the business, and they start building that. So the naivety comes from they hire someone, they put pressure, or like a couple of people, they put pressure on those individuals. Those individuals want to demonstrate that they can, like do state of the art, and that means that they will actually start aiming high. So they will take very complex models. So, like they will say, oh, deep neural networks or, like random forests are the way to go because that's what we read in the paper. So they start playing with those, they start implementing those. And it's a bit like, you try to build a car and, like without really understanding I don't know, like the what does it take to build the right chassis or whatever. So you take like, you just take four wheels, you put them there, you tie them together, you put like the shell of the car, and then it's a car. It looks like a car, right? But then, like in the first turn, it will fall apart or it won't turn right or whatever, right? I mean, you need to understand, like how the suspension works, the dynamic, all those kind of things. So one of the challenge in data science is when you start too high, so you take very complex model, you will get the results to some results rather fast, especially today when a lot of tools are commoditized. But by doing that, you're actually it blocks you from really understanding well the data. So what I go in and do with a lot of clients I'm working with, I'm going and say like, okay, what's your baseline? Like let's think about, you have this data. What do you know about the data? What's the most, let's call it, stupidest model that like can take you close, can take you towards your solution? And that can be a simple linear regression, or can be like a simple decision tree, or can be like do your exploratory data analysis, learn about the data, can be some rules that you learn from that. And initially that thing sounds like, yeah, but like this is not the shiny nice thing, but it's necessary. You can't do proper data science development without those things. You can't skip those steps, because every time you're training an algorithm, you need to kind of have a baseline, a reference to compare it towards. You need to have a benchmark, right? So what your benchmark is, right? And you need to kind of start doing a lot of validation, a lot of experimentation. So if you skip those basic steps, then like you already you jump too far, and then you don't it's very difficult to assess how good or how bad, or like you're doing there, right? And I can't tell you how many times I've seen like teams basically building an AI, so a machine learning model. uh, they do like they do it by the book, like they follow all the steps, like on uh, okay, we need to split the data like this, and we need to do this kind of cross validation, and we need to check about this, we need to do that, and they do it very nicely on the data sets that they have. But then when they get new data, new measurements and whatever, they realize that their models don't perform, or the AI does very poorly on that. And that's because you're skipping a lot of those steps. And I go back a bit to this process, and let's say naivety both of stakeholders. and like people involved. And again, it's normal to have these things because it's rather not rather new or whatever. It's new in the sense that it's more mass adoption is rather new, right? So everybody's trying. It's a bit, and probably you will be able to I mean, you've seen this, for example, in web development. I mean, putting a website up is not necessarily hard today because you have a lot of this low code, no code to do, right? But now taking that and actually developing into a scalable, like something that you can maintainable and, like all those kind of things, that's a lot of engineering and thought process and well design, right? And again, it's not about just reading a book or whatever. It's about experience. It's understanding that, okay, well, actually, like if we build this kind of database, like we will probably see a lot of migrations as we move, and like that's going to like take a lot of time. And I don't need to go into the detail, but it's these things where like when was as web development was more not was less used 20 years ago, and like there were very few people that were doing that. Today people look at web development and they see it very much as commodity, and they will believe that like it's easy, I'll put a website, right? Or I'll make an app and I launch it on like App Store or whatever Android store. But you know that first step is it's okay, you can do it, but then taking that and making something robust, reliable, and so on, it's still hard. And you see that naivety, even more with data science and AI development, because people say like, I get your data, you throw these things, and then we have our data-driven product, right? But reality is not like this, and we need to think about it. And the second, probably the second biggest challenge I see is that the stakeholders, the management, will come to the team and say like, they ask them the question, which from the management perspective is entitled, but they don't get a pushback. But they ask them like, how much time do you need to get to this performance of the algorithm? Which as the CEO or whatever, or director of a business or head of a group, if you're on the business or sales side or whatever, I think like you probably don't have a better way to ask that question, right? But then the naivety or whatever, sometimes the lack of experience on the other side of the team, they will say 6 months or 3 months or whatever. They will give a time, right? And that's what brings me back to the thing, which is data science is not engineering, because you know how to build various blocks, but the results, the performance, the targets for the algorithms are very much dependent on the data and some other things, and the signal in the data, and that's something you can't control, right? So it depends on the experimental design, depends on like signal in the data, depends on the amount of data, depends on how you're using uh, that like that particular problem. It's not like, okay, how much time do you need to do this database transition or whatever? How much time does it take you to write X amount lines of code? I mean, that's a quantity that you can estimate a bit better. So this second biggest challenge I see is that there is this unnecessary pressure put from the stakeholders towards the teams, and they say, how much time do you need, or what do you need to get there? And then the teams will kind of come up with an estimate, and like reality is like never, no one I've seen kind of hit that to some degree. And what I'm trying to work with them and teach them is like, look, it's you can't. I mean, it's good to say like, this is to put a target and say this is what we need to get, right? So we need accuracy of, let's say, 85%, or and then you have different metrics like precision recall, or like sensitivity, specificity. Depends on, like, if you go towards clinical healthcare, they will talk about, like sensitivity, specificity. If you go towards, like, I don't know, fintech, and then they will call precision recall and so on. I mean, similar terms, like all things around true positives, false negatives, all those kind of rates. Um, so it's good to put a target, but actually, I think the teams and the way how you need to assess the performance or whatever the development of the team should be what I call maximizing the learning. So rather than say how much time do you need, like to get to this, like accuracy 80%, you should basically say like, okay, look, we need that we need to make sure that in 2 weeks we know more that we
Mm.
know today, and that we improve the accuracy, like, slowly, 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 like even if we went from 70% to 71%, like we went into that particular direction. So it's about the process, right? Rather than saying like, okay, we need to hit this within 6 months because otherwise we can't, like sell the product. That's not how it works in data science, right? Because again, you can't control all the um,
Deliverables and
yeah,
outcomes. Yeah.
but you can't control the, so you don't have control on the data, right?
Mm.
Unless you work in a very, like simulated type of environment. You simulate your data and try to do something. So,
Mm.
like you don't have control of all the variables. So then the best thing to do is to make sure that, like you're you check, you have all the checks in place, that you turn the data upside down, that you try, you know all those kind of methods. And you need to kind of aim towards this increasing trajectory of improving and get it, learning more from the data. How much more you can learn, who knows? I mean, case in point, and like I'm sure there are people that will probably not like what I'm going to say, but like if you look back 5 7 years ago, people will say like, oh, by 2020 there will be autonomous cars on the road. Reality is that they are not. And like you can argue, yes, but Tesla can, or whatever, they show that they can do this
Mm.
20 miles, like fully
Mm.
autonomous. But when you look at it, it's like, well, actually, like how much mapping they did on that particular thing, and like how many trials they did, and like they show you the like one, like their best case scenario and all those kind of things. And reality is like, we don't have. I mean, like if I, I'm in Cambridge now, London is not far. If I go to London, I probably not going to see any autonomous car driving in London. Um, and the same in US. I mean, the fact that they can do it, like for short parts on,
Mm.
like on motorways or some roads or whatever. But again, it goes back to my point that you can't say, like within this time frame we're going to solve that problem, because you don't have control of all those variables. So that's probably one of the learnings I would like people to take away.
Yeah, completely agree. And I was about to ask two more questions, but I think you answered both of them in this question only. First question
Okay.
was, what is the baseline for any organization to start with? And you mentioned that these questions, that what is your baseline, what do you want to achieve, and what is your initial step towards it? So that makes perfectly sense. And secondly, my question was how the naivety of these business stakeholders impacts the solution, and that you also mentioned that they comes with certain timeline pressure, and those technical people who are in the pressure or they wants to deliver something, they just give the arbitrary estimate sometimes, but that is not the actual work or the output they'll be able to deliver in that time. And maybe it's also possible that they might be able to do something with smaller data set just to create a story, tell the story, to pitch for the product or something, but in the real time it might not work with the actual data or with the diverse data, or it might give the
Yeah.
biased results, so to say. So
Yeah, I mean, I don't know how much time do we have. I'll let me repeat uh, or maybe give a bit of a different flavor to this. I will say that most often than not, what happens is uh, because of this pressure, because the estimate is not right, because you can't control, and because the team, like to some degree, most of the time, the data science team is with the hands tied for the
mhm,
various reasons. That first, they overpromised. The second reason is they don't have the right data. The reason is like their assumptions didn't go. But anyway, they end up being with the hands tied. Most of the time, what happens that results into less into products that are brought to market that are not uh, like not to the standard that they need to be. So
mhm, mhm,
like in the end, uh, the like the team will hack their way through, right?
mhm,
And then especially in healthcare, like that manifests in a few things. And like there were a few stories over the years where like some companies brought some products, they hype them, but reality is that they especially in healthcare, they start hurting people to some degree, right? Because like they drive the decision making, and then they realize like, oh, this is very biased, or this is like too random or whatever to the people within like now with this chat gpt talk about hallucinations and whatever. So you need to understand about those challenges, because like if you understand about those challenges, and if you understand about those uh, issues, then you can factor them in. But most of the time, those products that are not ready to market are pushed to market.
mhm.
And uh, what happened, it's that you end up with a product that is not solving the problem you have, but
Mhm.
also there is a lot of frustration within the team. So I'll give you I mean, give me 5 more minutes, I'll give you another example that actually for me was very insightful. So this was North American company that basically I started working with them like 4 years ago for a year. They had a very interesting product, and their product was to take healthcare claims. So like you get
Yeah,
an accident,
yeah.
like you break your leg or you get hit by a car or whatever. So to take that claims and digitalize them, for the reason that the way how the insurance space works is very much still pen and paper, even probably today. So like the insurer will send this file of PDF, so like 500,000 PDF uh, pages to, let's say, a clinician that knows if you broke your leg or whatever, knows about that. So let's say a chiropractic or something, or I know you hit your eye, so they send it to a optometrist or whatever to kind of review this claim, right? And then this individual will kind of go towards those kind of like click to the PDF pages, try to read through them. Whereas, what they should do, they should, like again, maybe, they just should say, I want to see the analysis, this blood analysis, or I want to see this kind of analysis, or I want to see if this patient had this or whatever, right? So it should be more search driven and more, like,
Mhm.
yeah, maybe we can talk about ChatGPT. But anyway, so this was like 4 years ago, and then the team there was like so ambitious that they were like, so first they didn't have any or much real world data, and
Mhm.
they start building this framework where they were taking these PDFs, which were like mix of digital generated but also scanned PDF. So like, and then the scan
Yep.
will be like, an intern will go, will put a page on the copier, like
Yeah.
tilted. Anyway, so so they build all this, like they use OCR libraries, and they build all this system where they were trying to extract as much text from this, and and like the team was telling the founding team, that the data science team or whatever, the engineering team was telling them, yeah, we need another month or a couple of weeks, and we'll do this, and we'll do this, and and they were like, they were obviously, like 6 months later, still not having the product, because actually taking these, like documents and fully digitalize them and make them searchable and make them, like actionable, it's very, very hard. I mean, this is a moonshot project that, companies like Google or whatever can probably do if they put 100 engineers and a lot of resources on it, right? And they can do them again. But so what this company struggle. So they were a startup. They were kind of like, yeah, give us a bit more time. We'll get there. We'll get there. We'll get there. And when I got in, working with the founders and with the engineering team, data science team, there was like, we realized that actually we have, uh, let's say, half of a product, and the half of the product was basically, uh, we had like a index, so we were able to generate an index for these documents. So like if I give you 1,000-page document, basically we were able to extract the title, dates from each of the pages, and also say like, this form has 4 pages, or this letter has 2 pages. So basically we start generating a table of content. And then what we agreed was like, well, actually, how about this? Like we go to our clients, we say like, look, give us your documents, we'll give you a 24-hour process, like allow us a 24-hour processing time, let's say. We'll process this thing, and then here's a dashboard or whatever, like a screen, where you go and then you navigate this table of content, and like you'll see still the scans or whatever, the pictures, right? I mean the thing, and like, will this be helpful? And they were like, yeah, absolutely. So then and again, like, even that table of content, actually we needed to have some curators. So like we had some people with clinical knowledge or whatever knowledge of the thing, that they were, like, so basically we had this AI that were generating, extracting information. Then there were the curators, then they were like arranging, like filling in some fields there. But then, within a couple of weeks, we end up with a product that actually the team enabled the management team to get, I think, like 5 to 6 pre-sales. So like we went and we got the clients, and then you will say, okay, but still you didn't solve the problem. Yes, but then we solved something better than that, which was that all of the sudden the team start having 10 times, 100 times more data, because these clients start sending them data. So then was like, all of the sudden the team there start putting a framework around where it's like they were able to get real data. They were like, okay, let's try to so we have this thing, we can do the OCR, we can extract this minimal, let's say, metadata out of it. Let's see what's the next step. Can we, like extract double amount of fields? Okay, now that we have this thing, can we actually do this kind of thing, and so on and so forth. So again, it's about, I go back to what I was saying earlier, it's about that process. It's about making sure that you're maximizing the learning, and that, like at the same time, you're also creating value for your customer, right? Because by creating value for your customer with your product, like then you can get data from your customer, and then you can start improving your AI, right? I mean, and if today you have a data set that, let's say, has 10,000 data points, if you have 10 customers using it, maybe in 6 months you'll have 1 million data points. Now, for 10,000 data points, you can use, let's say, not all. So you can use particular type of machine learning algorithms. Whereas for 1 million, that universe of tools you have at your disposal increases, right? Because like it allows you to use, let's say, deep neural networks, or like more fancy things. You can do more complex modeling. Yeah.
Mhm.
Anyway,
Makes
I'll
sense.
pause for a bit and I let yeah.
Yeah, it makes sense. I think it also, the approach which you mentioned, I think it also helps to make it more sustainable, so that money also flows in. Simultaneously, they also have access to larger data, so in background they can work on what they actually want to achieve. So that's nice. That's a nice approach. Last question that I wanted to know your point of view on is that you are in this life science domain for nearly around 2 decades now. Uh, what and it's in data science especially, and you're working on the data science since when people are not even talking about it. Now these days there are a lot of hype around AI, machine learning models, deep learning, generative AI, and so on. So do you think in the drug discovery domain, life science domain, there are certain areas which is still untapped or not explored fully? Or do you think that people have, started, uh, you know, working on those areas, but there is a scope of making it more efficient, uh, those areas? What do you think?
Yeah, very, very good question. Uh, how much time do you have? So, look, realistically, uh, science and like data science and all the things around AI, all those things are incremental. So yes, people weren't necessarily talking about AI, or I don't know, random forest or large language models or all those things 20 years ago. Though AI, probably there was a big hype around AI in the 70s, 80s, or around 80s, where actually the OCR, like the optical character recognition.
Mhm.
So that's the that application was solved with neural networks. I mean, that neural networks proved to be and I think that work happened around 80s, 90s, or maybe 70s, 80s. I don't know. Let's call it 80s.
Mhm.
So, and then like there was a lot of development also in um, NLP, natural language processing, in the 70s, 80s, again, like during the Cold War, where like everybody, like the West wanted to translate books from the Soviets and China and whatever, all those kind of things. So a lot of those technologies, like there were spikes, right? um,
Mhm.
there are cycles that you see, right? So like right now, the cycle we are in, it's very much driven by the increase in computational power. And
Mhm.
it's basically, if you I mean, like people talk about GPUs. Reality, I mean, what
Mhm.
really happens, GPUs enable parallel processing and
Processing.
vectorial calculations, right?
Also, the available
So
libraries where people just
yeah,
use it and
yeah,
not.
absolutely. But again, it's a race. It's a race.
Yeah.
Like it's one pushes each other. And of course, libraries, as you were saying, earlier when I told you about my package in bioconductor, I mean, that was this ecosystem of libraries in R that were solving biological problem. And
Mhm.
the interesting thing is that it's still one of the most used resources, like to uh, to apply those tools for biology today. Over the last 5-7 years with Python, like if you think about Python 10 years ago, Python didn't have the um, data frames, and like, so Python was the language to go for, like if you wanted to do object oriented programming, and like scripting, all those kind of stuff, but didn't have this data visualization and
Mhm.
like data manipulation capabilities. So there are cycles, right? So the fact that today we have this huge computational advance enables, like some of the tools that were developed, so again, neural networks, to kind of take them to the next level, right? So I think people in life science, whatever in sciences, they always talked about some of those things. They call them differently, right? So, like in 2000, people are talking about data mining, was talking about information retrieval, was talking about, like statistical computing. Now people today call it just a bit different, like AI or whatever, all those kind of thing. And it's interesting. You have people coming from mathematics, statistics, they call the same concept differently and all those kind of things. Um, so so that's part of the problem. So, like a part of your question, which is, do you see this like, okay, revolutionary for today? I think it's important. I think it's helped moving some problem forward. Are there untapped areas? I would say one area that it's really, it's a bit of a passion of mine is the fact that today we still very unimodal from a data perspective. So you have very good algorithms that take images, and does something on the image, right? But you don't have algorithms that will take image and, clinical information and chemical information and put them together. I mean, in your previous podcast talking with Andrea, he was saying like, hey, we developed this framework for imaging and then we went um, to chemical compounds, right? And you see that. I mean, I think today we are still at a point where, and it's not. This is not necessarily driven by or whatever. It's not a limitation of the data science or machine learning, whatever. It's also a limitation from the fact that to measure this data is actually tricky. So you can't, like, and how do you bring it together? But realistically, we in life sciences we have these very complex systems that, by taking an image of that system is not going to tell you everything about the system, or is going to tell you very few about the system, right? But then if you take some other measurements, like you look at the protein levels, or you look at bloods, or you look at whatever, I know, and other things, then we'll do. So today what I see, there are a lot of developments that are very, like uses one type of data, or, like a couple type of data. So i think I think there is a huge untapped potential to basically be able to bring all this data together and build those multimodal models and understand a bit how we connect between this multimodal model. Um, so that's one of the things. Um, the the other comment I can have, which is, um, in my opinion, and this is very 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 personal, I would say, uh, you know, a lot of the biology knowledge and this, I mean, we have a lot of big assumptions, and we try to put mathematical models on top of those assumptions, on top of this biology. And most of the time doesn't work, which basically means that, we measure something, we use the data very smartly, and, like we make the best of the data. But reality is like when you put that in the system, in the biological system, things won't work because, you can't measure, like you forgot or whatever, you weren't aware that these other things were happening, and so on and so forth, or, your assumptions weren't as right as you thought, or as true as you thought. So I don't think it's a silver bullet. Like, I mean, we hear all those advances like, oh, now we can do protein folding with AlphaFold and alike type um, things. I mean, I see it incremental. I see that it will help part of it. But if we want to think about the, you know, drug discovery, health systems, whatever, it's basically solving one of the parallel threads, or whatever, it's optimizing one of the parallel threads. And in drug discovery, you will probably have 10 of these threads going in parallel. And by threads, you like you do your protein, your target identification, or whatever, hit to target, or whatever, all those different steps. But then you have other things, like you need to look at the regulatory thing, you need to look at the other toxicity of the thing and all those things. And then reality is that you still have to wait for these threads to happen before you move to the next stage and whatever. So we're not yet at the point where the current developments in AI is able to, in my opinion, it's able to uh, to make all these parallel processes like more efficient. I mean, it happens to one to the other. So yes, we are kind of gaining a bit of efficacy, if you want to say, but not huge. So yeah, it's a bit like you know you you you're running as a team, as a group of people, and like one of those people is very fast, like, but you're not winning until everyone is crossing the line. So uh, reality is like you kind of need to think about how you can move that group forward.
Together, yeah. Considering all these different aspects, makes sense. Well, yeah, that's it from my side for this, and I think it was really interesting and insightful conversation. I think there's every time I have this conversation with you around data science and AI, I think there's a lot more to learn from you. So we will have several podcasts in the future as well. But
I
last,
love it.
what will be your uh, advices to organization who wants to start a new AI vertical? What are the things that they should focus on? Of course, one, you mentioned the processes. Uh,
Yeah.
and what advice would you give to the individual who wants to start or wants to start getting into data science or want to start a venture in data science?
Right. I will say, I mean, I don't know, to be patient, to think that, like um, it, it takes time to get to a point where, like they will be able to deliver at a faster pace. They should aim high, but, like they should also realize at the same time that there isn't a silver bullet, and, like it takes time. I mean, you know, data is important, experience of the team is important. You need to, even if you hire very, very experienced people. So again, it's a matter of resources. So depending how much resources you put in, I mean, if you have millions and millions of dollars that you can invest in bringing a team, of course, like you'll bring someone that solved a similar problem before and do those kind of, and then you give them the resources to build that kind of capability, right? I mean, that's not, or you buy a part, you buy that capability from by acquiring a company or whatever, all those kind of things. But if you don't, if your resources are more limited or whatever, just think about that. You it's easy for people to talk about successes of, like, oh my god, look how good this, I don't know, chat GPT is, or, but you, in general, you don't context and trying to deliver that. So trying to get to that point too fast can be detrimental. So just try to be patient, be more systematic. uh, I would say hire people that work on those problems, because I've seen very often, like especially in healthcare, people will say we'll hire data scientists that come from a um, different field. And again, very smart people, nothing wrong with that. It's just that it takes time for those people to really understand the challenges of that particular field. And it's not just life science is the same. If somebody with life science experience go into, let's say, fintech, they will still have like they will still need to take time to understand a bit, like what works there, what doesn't work, and whatever. So, don't expect that, like things will kind of happen overnight. And I would say engage with with people that worked on those problems. If you can do it by, like getting them as, I don't know, advisors or whatever. I mean, yeah, I don't know. I think it depends. Uh, it depends on the particular challenge, but I would say just be patient and systematic on the way how you do it.
All right. With that, thank you so much, Adrian, for joining this podcast. I hope you enjoyed this conversation. And yeah, there were lots of learning. I'm sure our audience will also have really good insights on data science, the different approaches, and what are the things that they should keep in mind while starting with anything new in the AI or data science domain. So yeah, again, thank you so much for your time, and yeah, looking forward
Thank you.
to many more podcasts with you.
Thank you. It was a pleasure, and somehow I feel like I went a bit sideways, but hopefully it will be helpful for people in the audience. Yeah, it was a pleasure.